All right, here comes part 2, integrals. Integrals are very, very useful, but a little bit more difficult. Integrals are used to find the area under a curve. So here I've got another just random line on a graph. If I wanted to find the area under this curve, I could do it. It wouldn't be too hard. I would need to do something like, let's see. I need to find the area of this triangle right there. And then I'd have to subtract the area of this area here. Because this is above, so it's positive area, I guess, and this is below the x-axis, so it's technically like negative area. And you can't see it, but I was doing air quotes just then, negative area. So I'm not actually going to do that because it's really annoying. So it is rather annoying, even when you have a simple function, it's all straight lines. As a triangle, you do, I guess I could just say it, you do 2 times 3 would be 6, and then cut it in half would give us 3. So up here I've got plus 3 of area. Here I've got 2 things. I've got a triangle here. So that'd be base is 1, height was supposed to be 1, but I think I went too far. Oh, yeah, I did. Oh well. So that'd be 1 times 1 is 1, and then a half, that's a half. So this is like negative 1/2. And then this is a rectangle. I got 1 times 1 is 1. So I've got is 3 on top, negative 1.5 on the bottom. So overall, the area under the curve was positive 1.5 units squared. We don't have any units on this, so it doesn't matter. That's annoying. And you can't even do it for a function like this. I mean, how would I do that? So what I do is I take an integral. Now there's 2 different kinds of integrals. There's something called a definite and an indefinite integral. An indefinite integral is when you just integrate the function. And it's actually not very useful because you end up with this thing on the end. It's a plus a constant, so you don't really know what's going on. We're not going to use that very much. Most of the time we're going to use an integral that has limits on it. So let's say, for instance, that I wanted to find the area from, let's say I wanted to find, I'm going to try and shade it here, I wanted to find this area. Right here. So that's from x is negative 1 to x is 3. Oops, oh, no, what'd I do? Okay, I'm back. Sorry about that. Put it back in full screen. Okay. I don't know what I just did. I don't know why I did that. Okay. Anyways, back to work. So I want to go from x is negative 1 to x is 3. I want that area. What I do is an integral. So I'm going to do the integral of this. The symbol for an integral is really cool. It's my favorite thing. It looks like a long, skinny S, kind of like this. That's the integral sign. I think it has a real name, but no one ever uses it. Then I put, actually, the best way to do it is like this. Meep. Yeah. Inside, I put what I want to integrate. So I've got negative x squared plus 9. And then we put this thing on the end that's dx. So, oops, I forgot that. Oh, I should explain where I just came from. Okay, you remember that dy over dx thing before? You know, it equaled stuff. I'm basically I'm saying this now. I'm saying that. I multiplied both sides by dx, put it over there. So I get dy equals that stuff dx, and then I put an integral sign on both sides. So what I do is when I integrate just dy, I get y. So I'm finding a new function, y. Okay? The other side's not so easy to integrate. There is a rule, and it's not as easy as the derivation rule, but it's not too bad. Here's how it works. you take the old exponent and you add 1. So I'm going to take, well, first off, I had that negative, so I'm going to leave it there. I have that old exponent was 2. I'm going to add 1 to it. So instead of x squared, I'm going to have x cubed. Then I divide by the new exponent, like that. Plus, I had a 9 there. The old exponent, remember, is, if it's nothing there, it's x to the first. I'm sorry, x to the 0. Why did I say that? X to the 0. So if I add 1 to 0, I get 1. So I get x to the first, which is just x. I divide by the new exponent, so it's divided by 1. Okay. Now, if I was doing an indefinite integral, I would do this, plus a constant. And that constant could be anything, which is why that's not very useful. Instead, I'm not going to do that. I'm going to put limits on this thing. Limits are these little numbers. I'm going to use black so they show up a little bit better. You put them at the top and the bottom of the funny little s thing, and you write them in where you want to start and where you want to end for your x value. So I want to start at -1. I'm going to put a little -1 right here. I want to end at 3. I put a little 3 right here. Now when I get to this point, when I've gone from this pink line to this blue stuff, I'm going to put those limits on here again. What I do is I do a solid line, no curves, like that. I put the limits on there again, just like before. And then this is how I use them. What I do is I plug the top number in for x. It's going to go in there and in there. Plug them in. So it's going to be -3 cubed over 3 plus 9 times 3. I'm leaving out the over 1 since it's not really necessary. Okay, so you do that. Put big old brackets around it. And then you're going to subtract the same thing again, but this time you put the bottom number in for x. Put it there and put it there. Boop, like that. So now I'm going to have a -1 cubed over 3 plus 9 times -1. Now you've got like a nasty math thing, but totally doable. And you're going to pop out an answer, and that answer is the area under the curve. Let's see, what is the answer? -3 cubed is -27 divided by 3 would be -9. Is that right? Berate me tomorrow if I'm wrong. Plus 9 times 3 is 27. Minus -1 cubed is -1. Negative that is 1, so I end up with 1/3 plus a -9. So that's -9. Okay. So let's see. I've got a -9 over here. I've got a plus. I got a minus -9 over here if you distribute through. So those are actually going to go away. They're going to cancel each other out. So that's going to go. So I end up with 27 minus 1/3. So not a nice number. Oh gosh, what is that? That's, well, it's 26 and 2/3. I hate mixed numbers, but that's what I'm going to go with. Okay. Not a nice number, but anyway. There are other functions that have other tricks. This is how you find an integral for a polynomial only. I'm going to show you some other tricks later as they come up. That is the end of part 2.